Okay, for number 7, I'm seeing a function f of x, and that function is the arctangent. And they want it to be centered at 0. So my goal over here is to find something, and I certainly want to go through differentiation. It looks pretty tough. So what I'm going to do is I'm always relying on that geometric. And what I notice about this over here, I'm not going to say it's exactly geometric, but I know that the antiderivative of this over here is equal to the arctangent of x. All right, plus some constant integration. I'm not worried about that at this point. And I'm looking at that, and I want to just write this down. So I write down 1 over 1 plus x squared. What does that equal? Well, I can write it down so it looks more geometric in form. So 1 minus x squared. That hasn't changed it. And I can write this down as 1 plus minus x squared plus minus x squared squared plus minus x squared cubed. You get the idea. Go on forever. Where does this converge? Here. Okay? So let's keep writing it down. So 1 over 1 plus x squared is equal to 1 minus x squared plus x4 minus x6 plus yada, yada, yada. What I'm going to do now is integrate both sides. I'll integrate this with respect to x and integrate this with respect to x. What do we get over here? What we wanted. Arctan, whoops, of x. I need to put the constant somewhere, and I'd like to put it on the simple side, which is the left side for me. What do you get on the right side? X minus x cubed over 3. Let's see, plus x 5 over 5. You know, I'm starting to notice there's a pattern to this, so let's put this down 1 and 1 there. All right, what do you get next? Minus x7 over 7. I'm going to say plus yada, yada, yada. I got to pick an x that's easy, and my right-hand side is the problem I'm worried about. And I'm going to say an easy number on the right-hand side would be to let x equal 0. So let's take a look, see what happens. What's the arctan of 0? Is 0. So you can get c equals, on the right-hand side when you plug in 0, I get 0. So c is 0. So the arctangent of x is going to be this thing over here. Well, let's write this down as a sum. Whoops, eraser out, doesn't look right. It's a sum, n equals 0 to infinity. It alternates. I'll put down minus 1 to the n. If I'm starting at 0, it's going to be plus, minus, plus, minus. That works out pretty good. I'm looking at the bottom, it's 1, 3, 5. It's going up by 2. So I can say 2n plus 1. I want to check that. At 0, you get 1. At 1, you get 3. At 2, you get 5. At 3, you get 7. Looks good. And the power is the same. What do you get over here? Let's see, 2n plus 1. All right? Now, I know the radius over there. I'll tell you why I know the radius. It's over here. The radius is 1. But what I don't know is I don't know the interval. And the reason for that, integration, it may actually include those endpoints. So let me write this over here for you. X and minus 1 to 1. Well, let me try the 1 first. What do you get? The sum, n equals 0 to infinity, minus 1 to the n over 2n plus 1. So this converges, all right? Alternating series, fifth description, decreasing, and the limit, it goes to 0. Let's do the other one, a little more complicated, but I still have to write it down, right? So what do you have here? N equals 0 to infinity, and then you get minus 1 to the n, then you get minus 1, and that's going to be 2n plus 1 now. And that goes over what? 2n plus 1. All right, let's see if we can figure that out. And you get n equals 0 to infinity. This is going to be 2n plus 1. And on top, what do you get? You get minus 1. And then what do you get there? Let's see, you get 2n and n is 3n. All right, now, it's an alternating series, just the other one, but let me make sure you understand that. So if I just write this down, you know, minus 1, at 0 would be 1. What's the next one going to be? Minus 1. Well, if you put 1 down, you get 4. I hope you get to realize it goes up by 3. Minus 3, 7. minus 3, 10. So, looking at it, negative, put this down, minus 1, plus 1, minus 1, plus 1. It's alternating series. This also converges. Both endpoints get included. Let's put our interval down, and once we're done with it, we're going to look at the key to make sure we didn't make any mistakes. What does that mean? I'm going to look at it, and this is question number 7, and I'm looking at the series expansion for arctangent of x. What is it going to be? Minus 1 to the n 0 to infinity. I got this, I got this, I got this, and I got this. And we're looking at the key to verify that. Thank you.